This is the first of a two-part learning lesson on measurement. These are basic measurement concepts. Let's start this learning lesson with a brainstorm. What are some possible ways to measure this ice cream cone? Try to come up with as many as you can. Be creative. Here are some of the ways I thought of. Did you come up with any of these? When we teach basic measurement concepts in elementary school, we teach it in this progression. We start with comparing different attributes like length, weight, volume, time, etc. Next, you teach students to measure with non-standard units like paper clips, their hands, cubes, etc. Using non-standard units like our hands and feet build an understanding of why we need standard units that are all the same size. Then we have students start measuring with standard units. Let's make sure you understand the difference between these 9 measurement attributes. Try this problem on your worksheet by drawing lines to match up the attributes with the description that matches. Here are the answers for the first part of the matching. People usually do pretty well with length, a one-dimensional attribute, and area, a two-dimensional attribute. Perimeter is a specific type of length attribute that measures length around the outside of a two-dimensional shape. Volume is a three-dimensional attribute, like the amount of liquid in a cup. Weight and mass are generally thought of as the same attribute, but they actually measure different things. Mass is a measurement of the amount of matter something contains, while weight is actually a measurement of force. It's the measurement of the pull of gravity on an object. You may remember learning in science that your weight on the moon would be different than it is here on the Earth. That's because the gravitational pull on the moon is much less because the moon is much smaller than the Earth. Your mass is the same no matter where you go, but your weight could differ. Mass is measured by comparing a known amount of matter to an unknown amount of matter using like a tool like a pan balance. Weight is measured using some kind of scale. On Earth, we consider weight and mass to be basically the same if we assume everything has the same gravitational pull. That's why we often consider them as the same attribute. Capacity is often mixed up with the attribute of volume. These are similar, but not exactly the same. For example, this jar can hold a certain amount of liquid. Let's say it can hold 20 ounces. That's its capacity, its potential. Maybe it's only filled with 8 ounces though. The volume of liquid in this jar is 8 ounces, even though the capacity of the jar is 20 ounces. The remaining attributes should be fairly simple to understand. We can measure time, or duration, in hours, minutes, and seconds. We can measure temperature in degrees Celsius, Fahrenheit, or Kelvin. Value we will assume to mean related to money for a measurement unit, and in the United States, we measure this with our base 10 system up to the hundredths place to represent dollars and cents. How do we teach students about these attributes? An understanding of these attributes is part of number sense, so seeing these attributes in the world around us is very important. The concept of each attribute is developed through gross comparisons of objects and pictures that allows students to develop a sense of the attribute and recognize the sameness. Generally, we want to use a compare and contrast structure and develop comparison vocabulary phrases. Here's an example of a comparison activity we might use at an early age. We could show students 2 images or give them real concrete objects and ask them those comparative questions. Which of these objects is longer in real life? We could also ask them which one weighs more. For capacity, we could give students 2 containers and ask them which container could hold more of something. If you're just developing this sense of attributes with your students, we have to choose our examples very wisely so it's obvious which one is longer, or which one weighs more, or which one holds more. Once students understand the different attributes, you can help them learn to measure with non-standard units. Students learn how each attribute is partitioned into units of equal size and the resulting measurement is an accumulation of those units. For example, you can have students show the measuring of the length of a table using straws, or measuring how many marbles fit inside of a jar. While measuring with non-standard units, students demonstrate and practice a procedural strategy for repetition of that single unit, and they can begin to predict or estimate the measurement. The key is for students to see that you need to measure with all of the same size object. If you had straws of all different lengths, or marbles of all different sizes, you're not really measuring something. Everyone would get a different answer. Here are a few more examples. Measuring with non-standard units for weight is the same as measuring mass. We use a comparison. How many pennies does the toy car weigh? You could use a geoboard and rubber bands and have students count how many generic units long the perimeter is. An important measurement concept involves an understanding of the inverse relationship between the size of a unit and the number of units needed to measure an attribute. In other words, the bigger the unit for the measurement, the fewer of them would be needed to measure your item. If I measured a table with these units, ribbon strips, small paper clips, and big paper clips, I would need the fewest of the ribbon strips because it's the largest unit of measurement. I would need the most small paper clips to measure my table because it's the smallest unit of measurement. That's that inverse relationship. Once your students are able to use non-standard units, you can begin to link your measurement unit to your science instruction. Ask students to conduct some experiments using the scientific method, where they make an observation regarding the attributes of some things in the world around them. They can pose a question like, which holds more, the tall glass or the short fat glass? You can ask them to make a hypothesis and then conduct a mini experiment to test that hypothesis, draw conclusions, and report out their results. This can be done even in early elementary school. It's your turn to think about some activities to develop a sense of attributes. On your worksheet, there's space for you to sketch or describe an activity using the scientific method that would help students understand and compare objects, thinking about a specific attribute. I want you to choose between attributes of weight, area, or time duration for your description. Before we can move from non-standard units, we need to help students discover the need for standardization. I like to do an activity where each student measures the length of the classroom with their own feet. The class can all report on a chart how long the classroom is. When we all get different results because everyone's feet are different sizes, then we can have a class discussion about why we got different results and what they think we should do about it. At that point, you can introduce the standard unit of a foot as our solution for people's feet being different sizes. This is actually the reason for all our standard units. We need to be able to communicate with each other, so standardization puts us all on the same page. In mid-elementary school, we move from measuring with non-standard units to measuring with standardized units. In the United States, we use standard customary units, like inches, feet, gallons, pounds, seconds, and Fahrenheit. It's important you provide instruction for each unit of measure separately and give the students a chance to apply what they know from non-standard units. You also need to help them build fluency with reading and writing the abbreviations for those units. Help build the concept of specific attributes by using examples and non-examples. Here's a task that asks students to circle objects that would be about an inch long in real life. Here's an example of using discrimination examples to help students make decisions about selecting appropriate units. You can also use a scientific method here to test these hypotheses. You want to build fluency with units, so think back to our lesson on declarative knowledge. Find ways to help your students practice quick identification of units, like through games, self-correcting practice materials, timed probes, and flashcards using constant time delay. Value with regards to money is one of those attributes with which students need a lot of declarative practice. Students need to be able to identify coins, as well as how much they're worth. Eventually, they also need to be able to skip count by those values. Measuring with standard customary units requires clear procedural strategies. Remember this procedural strategy checklist? You're going to put it to use again here. I want you to choose one of the scenarios below and write a complete set of procedural steps that would lead to the correct measurement. The steps should all include an overt action, should begin with a word that cues the student to act, and should be brief and generalizable. See if you can even come up with a remembering system.